Hello everyone, we are covering 8.5 in this video. 8.5 is on adding and subtracting rational expressions. Our goal is to add, subtract, and simplify rational expressions. To do operations with rational expressions, we can use what we know about operations with fractions. We will use common denominators and equivalent fractions using the least common multiple. We're going to skip example 1. You won't have any homework questions like that. Before we get to example 2, though, I do want to just review some brief fractions with you, and you'll see that in example 2 we're going to be using the same techniques that we would with these fractions that you learned back in elementary school. The first one is 1/5 plus 2/5. Notice that 1/5 and 2/5 both have the same denominator. They have a common denominator already. So we're going to keep that denominator of 5, and we simply add the numerators. So 1 plus 2 is 3. Since 3/5 is already simplified, that would be our answer. So that's if both fractions have a common denominator. If we look at the second example, 1/8 plus 3/4, our denominators are 8 and 4. They're not common. This is an example where we can just multiply one of the fractions to force the two fractions to have a common denominator. So if I multiply 4 by 2, then I'll end up with a denominator of 8 there. But if I need to multiply the denominator by 2, I also need to multiply the numerator by 2. That way we're ending up by multiplying by 1, and we're not actually changing the original problem. What this does is it becomes 1/8 plus, now multiplying across, 3 times 2 is 6, 4 times 2 is 8. So we can think of this original problem, 1/8 plus 3/4, as the new problem, 1/8 plus 6/8. Now I have the common denominator of 8. So we can keep that common denominator of 8 and add the numerators. 1 plus 6 is 7. 7/8 is already simplified, so that would be our answer. And then one more with just fractions, 1/3 plus 1/2. 3 and 2 are not common. The denominators are not the same. In this one, we actually need to multiply both of the denominators by a number in order to force them to have a common denominator. 3 and 2 have a least common multiple of 6 in common. So I need to multiply the first fraction by 2 over 2 and the second fraction by 3 over 3 to force them to have that common denominator of 6. So this new expression would be 2 over 6 plus 3 over 6. Now they have common denominator of 6. We can keep that denominator, add the numerators, and it becomes 5/6. Hopefully you remember most of this from elementary school. With these adding fractions. Now we're going to do something very similar but with rational expressions, but we're going to use those same techniques that you did in elementary school. So let's go ahead and look at A. We have 5 over 3x plus 4 over 3x. Notice that both of the rational expressions have a common denominator already. So we're going to keep that denominator, just like we did in that first pink example right above, and then add the numerators together. So 5 plus 4 is 9. Check and see if this is already simplified. 9 over 3x is not simplified because both 9 and 3 are divisible by 3. So if I divide both of those by 3, we end up with 3 over 1x. But we don't need to write the 1 in front, so it's just 3 over x. That's simplified. We added. That would be our solution. B, we have 3y over x plus 4 over y. Our denominators are not common. They're not the same. So we need to force them to be the same. Notice in the first rational expression, 3y over x, I have an x on the denominator, but I'm missing y. So to force them to have the same denominator, I'm going to multiply the first one by y over y. And in the second one, I have a denominator of y. I'm missing the x. So we need to multiply that one by x over x. Oops, sorry about that. So now if you look at the denominators, we have x times y on both of them. Y times x is the same thing as x times y, since multiplication is commutative. So I can now think of these as y times 3y, the numerator becomes 3y squared. And then 4 times x is 4x over y times x. Again, multiplication's commutative, so I'm going to write it as xy. That way they're in alphabetical order. Now I have the same denominator, so we can keep that denominator of xy and then add our numerators together. So we have 3y squared plus 4x. Since those are not like terms, you cannot actually add them together, so you just leave it as 3y squared plus 4x. There's nothing that we can simplify here, so this would be our answer. Looking at C now, we have x squared over the quantity of x squared plus x minus 2 plus 4 over x minus 1. Anytime you have something like the denominator of x squared plus x minus 2, a lot of the times it's helpful to try and factor that, and you'll see why in just a second. So x squared plus x minus 2, we need two numbers that will multiply to negative 2, and at the same time those two numbers will add to 1. So that would be 2 and negative 1. So x squared plus x minus 2 factors to be x plus 2 times x minus 1. Notice here that rewriting it as x plus 2 times x minus 1, I can see that the other denominator of x minus 1, they have that in common, but that second rational expression, the 4 over x minus 1, is missing a factor of x plus 2 that the first rational expression has. So to force it to be the same denominator, I need to multiply 4 over x minus 1 times that missing factor of x plus 2 that the first rational expression has. Okay, so this becomes now x squared over x plus 2 times x minus 1, leaving it in factored form, plus, and then I have 4 times x plus 2. If I distribute that 4, we get 4x plus 8 over x plus 2 times x minus 1. And notice I changed the order there, which is completely fine since multiplication is commutative. Now that they have the same denominator, we can go ahead and just add the numerators together. So it's x squared plus 4x plus 8. You can't actually combine like terms there because there are no like terms. Over, just keep the denominator factored. If you really want to, you can multiply the denominator out, but there's no need to. So we have x squared plus 4x plus 8 all over x plus 2 times x minus 1. Always check and see if you can simplify. The way we would try and simplify this one is to try and factor the numerator of x squared plus 4x plus 8. However, this one does not factor. There are no two numbers that will multiply to give you 8 and at the same time add to give you 4. So since this is not factorable, you're not going to be able to simplify either. This is our simplified answer. Okay, let's look at one more together of this type. We have x squared minus 6 over x squared plus 2x. Plus x plus 1 over x. On that first rational expression, we can factor x squared plus 2x. It has a GCF of x. X squared plus 2x factors to be x times the quantity of x plus 2. This helps us to see what we need to multiply that second rational expression by to gain our common denominator. Both of our denominators have a factor of x already, but the first one has an additional factor of x plus 2. So to force them to have a common denominator, we need to multiply the second rational expression by x plus 2. And when we do that, you'll see that they have the same denominator. So this now becomes x squared minus 6 over x times x plus 2 plus, and then I'm going to go ahead and FOIL this out. X times x is x squared. 2 times x plus 1 times x gives us 3x. And then 1 times 2 gives us 2, all over x times x plus 2. Now that we have the common denominator, we can keep that denominator of x times x plus 2, and then add the two numerators together. Just make sure you collect like terms. So we have x squared plus x squared gives us 2x squared. And then we have one term with an x in it, so it just becomes plus 3x. And then we have negative 6 plus 2 becomes negative 4. And then lastly, just check and see if this simplifies. So you would try and factor 2x squared plus 3x minus 4. So you're looking at a times c, which is 2 times negative 4 and negative 8. What two numbers will multiply to negative 8 and add to 3? There's none, so it does not factor. So that means this does not simplify either. So your answer is 2x squared plus 3x minus 4 all over x times x plus 2. Go ahead and try the got it. Go ahead and pause and try the got it. Okay, looking at E, this example, you already have a common denominator of x squared. So all you need to do is collect like terms and add the numerators together. So you end up with 6x, and then you have 6 plus negative 6, which is 6 minus 6, or 0. So it just becomes 6x over x squared. This does simplify. There's a factor of x on the numerator and the denominator. So if you cancel out one of those factors of x, you get 6 over x. And then as far as what you would need to eliminate to make the domain work, it would be x is not equal to 0, but don't worry about that. You're not going to have to do that on the homework. I included it on the solutions for the got it, but you don't need to worry about it. And then on F, notice our denominators are x squared minus 4 and x plus 2. X squared minus 4 factors to be a difference of squares, so it factors to be x plus 2 times x minus 2. And then it allows us to see that we're missing the factor of x minus 2 on our second rational expression. So you need to multiply 5 over x plus 2 by x minus 2 over x minus 2. So this gives us 4 over x plus 2 times x minus 2 plus 5 times the quantity of x minus 2 all over x plus 2 times x minus 2. If you distribute the 5 on the numerator of the second rational expression, you end up with 5x minus 10. Since you have a common denominator, you can add the numerators together. So we have 4 plus 5x minus 10 becomes 4 minus 10 is negative 6, so 5x minus 6 all over the quantity of x plus 2 times x minus 2. 5x minus 6 does not factor, so this does not simplify any further, so that would be your solution. And then as far as domain, you would have to exclude negative 2 and 2, but again, don't worry about that for this section. The other type of problem you'll be asked to complete in this section is to simplify complex fractions. So let's look at A together. We have 1 over n all over n over n. Another way of thinking of this is that we have our top fraction divided by our bottom fraction. Our rational expression divided by our bottom rational expression. Now, when we're dividing fractions, when you learned that in elementary school, you would always take the first fraction, and instead of thinking of it as division, you would take the first fraction and multiply by the reciprocal of the second fraction. We're going to do the same thing here with rational expressions. I'm going to take the first rational expression and then multiply it by the reciprocal, which means switch the numerator and denominator around, of the second rational expression. I'll make a little note over here. So this is multiply by the reciprocal of the second rational expression. Okay. Didn't want to move from either. Try it one more time. Okay. And then we know that when we are multiplying fractions, or in this case multiplying rational expressions, you multiply across. So multiplying the numerators together, 1 times m is m. And then multiplying the denominators, n times n is n squared. That does not simplify, so that would be our answer. Let's look at one more. We have 3 over 5x all over y over x. Again, we can think of this as a division problem. 3 over 5x divided by y over x. Just like in elementary school, like we just talked about, instead of thinking of it as division, we can think of it as multiplying by the reciprocal. So it's 3 over 5x times x over y. If we multiply across, we get 3x over 5xy. Now this one actually does simplify. Notice there's a factor of x on the numerator and the denominator. So if we divide that factor of x out, we end up with 3 over 5y. Nothing else simplifies, so that's your answer. Go ahead and pause and try the got it. Okay, let's look at the got it. 5 over 4x all over 4 over x. You can think of this as division, so we want to multiply by the reciprocal of the bottom rational expression. So you can think of it as 5 over 4x times x over 4. Multiply across, you get 5x over 16x. Notice that you have a factor of x on both the numerator and the denominator that you can cancel out. So this becomes 5 over 16, which does not simplify any further. So that would be your answer. This is it. Just a reminder, remember a rational expression is in simplest form when its numerator and denominator are polynomials that have no common divisors. You simplify a rational expression by dividing out the common factors in the numerator and the denominator. Factoring the numerator and denominator will help you find the common divisors. So we talked about both of those up above while we were doing examples. So that's it for this section, and I will see you for the next one. I hope you're all doing well.